So the first thing is, if you have any question, don't hesitate and interrupt me in the middle of my presentation. This will be about HomeIO. It is my project, and this presentation is divided into two things. First, boring, some theory, history, and me talking about different things, and the other is demonstration. And as usual, demonstrations are more interesting than talking. So everything started with with idea of installing a wind turbine. My brother found that there are quite not expensive wind turbine which can be installed near home, and this can dramatically reduce utilities cost. So we said, maybe install this and check how it will be working. As you know, there is thing called marketing, and some people are very good at marketing. So you will. If you buy a wind turbine, you will have about 100 of złotys per year reduced bills. And I show you one sample about marketing regarding wind turbines. This is 3 kilowatts wind turbine, and the guy told that it will generate 10 kilowatts at 18 meters per second. I'm nearly sure that in 18 meters per second it will be destroyed. Because this wind turbine is produced in China, and there is no way that something is intended to generate 3 kilowatts and it can generate 3 times more. We have similar situation. Our wind turbine should have a dynamic tail which should brake and reduce current when wind was high enough. It was not working. We have one day the wind speed was constant wind speed was more than 10 meters per second, which is 36 kilometers per hour. But this is constant or average wind speed. There are some fluctuations, and if you have about 10 meters per second, max wind speed is probably 20 or 30 meters per second. And every fluctuation, and you will notice every fluctuation by generating current. So we were happy because our wind turbine was generating power as met, but 2 hours ago I went to check how is it going, and it isn't generating power now. It isn't, but it's rotating. So we lost connection to the generator, and we were unable to break it. And we have 3 blades which weighs 10 kilograms, and they're spinning like a chopper in our yard. So it was not. It was small Chernobyl. We managed to disassemble the system, and this event get us a lot of experience and knowledge, and we knew that we must do something better or abandon this idea. We are not of course, abandoning is not our style, so we went the other thing and wanted to make it work. We know that too much power is not okay, because we have to do something with that energy. We store it in batteries, but batteries have some limits. You can't put too much current in batteries, because they will boil, and they boil that day. And we need something to log measurements, to know what was going on. So we started creating a system to control this thing. At that moment, there was no Arduino. It was pre-Arduino age, so if someone wants to create something, you need to learn C and program a microcontroller. We used Atmega, the same as in Arduino, and there was available industrial automation devices, but they were pretty expensive. I don't want to remember how much they could cost. The first version was written in C++, and I used PHP to create graphs. Because that I knew at that moment. A few months later, I get to know about Ruby, and wow, Ruby is very nice language. I will use it for everything. It is good for everything, and it was good to do everything, but it had some costs. The costs were visible later. The cost was RAM and performance. Every variable in Ruby takes more RAM than it could take in C++. It's obvious, but you can think about it only in future, only in living system, when you have too much measurements and you need to store these measurements on disk, and that things we'll get later. I changed from Rails to Arduino, but it was only a small improvement. There was a session for real-time application that day, and I think using Node.js to publish one measurement is overkill, because we have about 10 types of measurements every 100 milliseconds. So this would be a lot of events. And about 1.5 years from now, I went back to C++. I'll tell you why, maybe sometime later. Okay, we had C++, but what about frontend? I used Ruby plus Rails, because I knew Ruby. And now I get rid databases, because database is I/O operation. If you get something to database, it will be written on disk. Of course, you can store it in memory, but it's not efficient. For frontend, I chose Gin, which is very fast web server. It is web server which can give you a response in nanoseconds even. Okay. HomeIO contains these key features. The most important is measurements, because you can't control anything, because knowing what the system is doing now. And in previous iteration we stored measurements in database or in Redis, and it was using a lot of space on disk or a lot of I/O operation. If you wanted to have a graph, for example, you will have to get a lot of measurements from database. It is time consuming. So I wanted to put some buffer of measurements into RAM, and of course vector in C++ is the most efficient way, because if one measurement from microcontroller from analog to digital converter is 2 bytes, you can create vector consisting a lot of 2-byte elements, and is easy in C++, and it is the most efficient way. You probably can't do it more memory efficient. One thing is buffer, the other thing is archive. If you fetch measurements, they are added to buffer, and if there is important change in values, HomeIO store this to archive. So you have CSV file as archive, and you can load measurements from this file and process them in external tool if you want to, and if you write it. The next thing is actions, because you can't control anything without having ability to perform an action, to control something. Overseers. Overseers are take measurement and action and watch measurements and execute action if proper conditions are met. And add-ons. Add-ons can be stats and can be custom overseers. You can write your own custom overseer in C++ code, and to do everything what you want. The next things are not so important. There are 2 TCP servers. JSON is using 2 frontends. There is user interface, console user interface written in ncurses, and I shall be demoing later. Okay. Web app. I wanted to make HomeIO as much easy to deploy, and everything what you want to set is in a main file. And you make changes in main file, compile, and web app will get every settings from backend. So you don't need to configure a frontend. Everything is fetched dynamically from precompiled backend. Web app should be also fast and easy deployable, because wind turbine instance is running on Raspberry Pi version B, not the second. The B version is I don't have 500 megabyte of RAMs, and I don't remember about CPU there. And you have to ability to access all modules from web app. Modules like measurements, action, and these modules. Yeah, these 4 main modules. Okay, now it's time for demo. I'm not the best Arduino programmer, and this is an attempt to utilize motion sensors. This is the motion sensor, and it has some processing to make it more sensible. This is some processing. Motion sensor is a digital device, and it says that there is motion or there is no motion. HomeIO can better operate on float or not decimal values, and this code is my attempt to make it usable for a human being. So you put you check if there is serial connection. You read command, because all communication with HomeIO, HomeIO is master and Arduino is slave. So HomeIO send command and Arduino return value. Commands are measurements and actions. This is...
May I interrupt you?
Yes.
How do we communicate each other?
At this moment via standard USB cable.
One more question. How
Yes.
fast, like how much data can you send in between them? How fast, like what's the, let's say, bit rate or something?
Yeah, this is a good question. I said that speed because at Mega microcontroller for wind turbine hardware operate on this board because this was the easiest setable for microcontroller speed or something. I don't remember at this moment, and I made it as a default value. But it will be easily you can easily change it if you need to. Okay, so if Arduino gets command M, commands are 1 byte. Take something and return and send it back via USB cable to computer. So you see, command is 1 byte to hardware, 2 bytes from hardware to computer. This is important thing because we have main file and we set command here, and we said that response will be 2 bytes. Of course, you can you can connect any sensor to Arduino, write your own logic, but you need to remember that put some code to allow fetching measurements. Okay, so this is sample Arduino code, and I think you can do something better and more interesting. And now HomeIO backend code. Okay, so this is the name. Name should be unique. Unit like volts, amperes, percent, anything. It is on a string used in interface. Command was described before. Response size was described. Coefficient, linear, and offset. It is if you have when you have analog to digital converter in Arduino, at Mega, or anything, it measure voltage from 0 to 5 volts and convert it to a number from 0 to 1023. So using this formula, you can convert raw value to real life float value. This is sample measurement, and I used default value linear 1 and offset 0. These values are used to determine when to archive, but it's not important at this moment. Priority is used only in frontend, and you create mesh type object, set it, add to HomeIO, and that's all. There are more objects. For this demo, I will delete everything, but I will comment it because there are descriptions and I don't want to create them later. Oh, this is important. This is the port used for communication. This is how much backend should sleep in microseconds between fetching next measurement type. For example, you have 10 measurement types, and this fetch first, sleep this value, fetch next, sleep this value, till the last one, sleep this value, and start from beginning. This is some values for storage, for archive. There are no overseas services not important. These frontend settings are used only to calculate time ranges. You can let it be default. Buffer storage. For example, if you run a backend and the backend will crash, the power will go off, and you have a nice big measurement buffer from 1 month. There is something that periodically store this buffer in case something crash. You run it next time, and this will load buffer, and you will have your data back. Yes, and this is the size of measurements. This is 2 million measurements per every measurement type in memory. So 2 million measurements, and I show you some demos later. Okay, we will compile it. Yeah, I'm using CMake. It's a nice tool to compile not small projects. I can tell you about it later. Okay, and I'm running it. This is the Encartas interface, and as you see, offset is changing. That means backend is fetching measurements. So if you the value is getting higher, I would need someone to make a movement.
Just curious, so you actually just watch when the blades pass, and that's your measurement, like that's how you...
This is only available sensor which I could take it here. I'm working with, I have 2 instances, and I will tell you about the sensors used in these instances. Now I have only infrared motion sensor, and if you
No, I was just curious, do you use that sensor to measure the speed of the turbine?
no.
Okay.
It's only a sensor. It was 10 zlotys and I just bought it. This is the real-time graph. As you can see, there are some noises. So, if I will be making a movement, there is more data.
Did you try like using median filters to filter out noise?
Not yet. It's only sensor to demonstrate something. I will demonstrate working instances, and there will be more meaningful data. But I wanted to show you that it's easy to use it, because some code, Arduino code, uploaded it and put some lines in a main file, compile, and run a frontend. The frontend has, as I said, has no configuration. Everything is loaded, so I will show you what is network. These are the settings for frontend. Because some systems are fast. Like wind turbine, you have change in values within seconds. For example, in soil moisture, you have changes in minutes or hours. So this is more the dynamic system, and this graph is faster. These are measurement groups not defined now, and information about measurements. Okay. If you want me to upload current version or change something in Arduino code, I can do it, but I think you know how to program Arduino. Okay. Future. I bought a solar panel, and I want to create a solar panel charging controller compatible with HomeIO, and check how solar technology is working. For example, you see that there is no sun at this moment, and if you have a cloudy day, I want to know how much energy it can create. Wireless communication. At this moment, Arduino is connected via standard USB cable, and nobody wants to put cables in-house. So I will be thinking about creating some wireless communication. I don't know which technology I choose, but this is the future. And use GPIO port in Raspberry Pi. As you said in your presentation, it can be better to have one board for Raspberry Pi than two boards, Raspberry Pi and Arduino. And fame, because I need people to tell me what is bad, what change, how tutorial should be written. So every idea and criticism is very welcome. More interesting instances. Yeah, this is wind turbine. Unfortunately, nothing is doing at this moment. There is no wind. You see that there is negative current, but this is only a wrong zero color. So wind turbine instances is not at this moment very interesting, because if it was working I could stop it and run it, and you could see how it is powering down, powering up. Okay, but I can load a full buffer. Full buffer is from April 11 till now.
How much power do you generate now? Like on a good day, windy day?
That's a good question, and I'll show you within a moment. Yes, this is a coil voltage. There are three coils, but the measurements are really identical. And you see when the turbine was working and when not. Okay, this is PWM, because there is artificial output resistor for braking, but braking was not needed. About your questions about power, yes, this is add-on, one of the add-ons, this wind periodic stats. So this is the day, how much energy it generated. This is the generator output. It's not how much energy we could use, because there are some conversions, losses, and other things. The next call time is how much time the generator was giving voltage from coils. It's a bad phrase, because it can't give voltage, but there was positive voltage at coils. So you can see that there was 22 minutes, 19 hours, 24 hours. This is similar, but when it generated current for charging batteries. This is resistor time, so how much time there should be used additional load to reduce speed. And these are max battery current, max voltage current, max coil current for statistics. The 6th of April there was 20 amperes, so it is quite 20 amperes times about 60 voltage is 70 watts. So it was nice wind speed. Okay. These are additional stats. As you can see, 30 amperes, it is the measurements should be filtered, and this feature is coming soon. Yeah, there's a lot of work to do. Okay, the other instance is which I deployed here in Poznań, in my apartment, is monitor moisture level in plants. Yeah, full range, buffer range is from February about 16 to now. So you see that there's a lot of measurements in a buffer. Okay, I have a few sensors, like light sensor, so you can see when it's day and it's night. Moisture sensor in one plant, another plant, and another plant. Internal temperature, internal humidity, external temperature, external humidity, and these are the groups. So you can click one and see moisture of all three plants. And yeah, these are some add-ons for statistics, but it's also work in progress. Yes, the wind turbine custom firmware, which is uploaded on Atmega, have measurements. Of course, it measure voltage on 3 coils, battery charging current, resistor current, and there was another current sensor, but this is offline now, and it control PWM brake resistor with very advanced algorithm, which I don't remember how it works now, but it works okay.
But it's based on a measurement?
Yes, this is based. PWM is based on coil voltage, because coil voltage is the least is the fastest measurement, because if wind turbine rotates faster, there is high coil voltage. Battery voltage rise slowly, and this is.
I'm just curious, like, how big are your batteries? Like, I mean, you don't generate much power if I got it right. Like, where do you store the energy? Like,
This energy is stored in old batteries from old cars, big cars, buses or something like that, and there is inverter, but I don't remember which one is at this moment. Oh, so thanks. That's all probably which I wanted to tell you. Is there any other question?
do you plan to scale it up? Do you plan to like buy a bigger turbine like the Chinese one?
Yes and no. Why wind turbines are harder to maintain than solar panels, and I want to use this solar panel to analyze how it is working. If solar panels are okay, then we will buy some 200 watt solar panels. It's between 500 to 900 zlotys per unit. So we will scale up. If it will be useful.
Are you going to use HomeIO to control your solar panels?
Yes.
For the measurements, or already getting some measurements?
I'm going to first to control battery charger, because solar panels has something like tracking max power point, and this tracking will be performed in Arduino, which is not the part of HomeIO, but HomeIO can enforce some different behavior into tracking. So HomeIO can, for example, could check weather forecast, and one of the previous iteration was using weather forecast to change thresholds of turning off and on inverters. So if you, for example, if there was going to be a heavy wind day, we allowed batteries to be more discharged. I don't know how HomeIO will be controlling solar panel at this moment, but there are inverters, artificial resistors for artificial load, and you can connect anything to HomeIO, and you can create some control rules and control it. The other ideas for HomeIO is people who have glass house when you grow plants, tomato or something. You can put some devices to water, and water moisture sensor, humidity sensor, light sensor, temperature sensor, and you can control this glass house and know how your plants are doing. The other idea is for monitoring aquarium. So if you have expensive fish, when you go for a week from home, you can see how your fishes are doing. You can, if you create a device which can give food for these fishes, and you can control getting food for fish. I've checked that there is oxygen sensor for water, so you can put in water and know if fish has oxygen. Any questions?
I'm just curious about solar panels. I did some stuff with them. Do you plan to track the sun as well?
No.
No?
I know at this moment no, because tracking is a mechanical thing, and if you have moving objects, it is harder to maintain. And I'm not sure at this moment, but tracking is not will not give you much more power.
30%, something like that.
It's third. So you will have to buy tracking device, and it costs, and it can break. So if this 30% is enough for buying this device, in my opinion, not, but time will tell.
It depends on how big your panels will be.
True. Yeah, but this is the question for the future.
Yeah.
Any other question? So thank you.